Hi everyone, my name is Rachel Sosa.
I'm Oscar Elizondo.
And I'm Lawrence Harrington, and today we'll be going into depth of the limits at infinity in horizontal asymptotes. So the references we use for this presentation are the textbook, LM 2.6 on Quest, and Khan Academy. So this first question asks us to draw an example with horizontal and vertical asymptotes and explain the differences. So when you look at the asymptotes, we're basically distinguishing where on the line these lines or this graph does not cross, or where the graph approaches but it doesn't reach, basically. So at what point does these lines like not pass or touch? So looking at this, you can see that the vertical asymptote of this line, we're looking at the x-axis where it doesn't hit, and it'll be 2 for this one. And for the horizontal asymptote, we can say that's 4 because it's like both of these stop or don't reach at 4 on the y-axis. So our vertical asymptote would be x equals 2 because we're looking at the x value, and our horizontal asymptote will be y equals 4 because we're looking at the y value. And the differences between the two, the difference between the vertical asymptote is looking at the x value, the graph approaches, but does not cross. So we're looking at the x value on the vertical asymptote and the y value on the horizontal asymptote. But the horizontal asymptote and the vertical asymptote aren't the same because you can cross actually though on the horizontal asymptote. You can cross them many times, so that's the difference. So the second question asks us, suppose that f of 6 equals 3 and explain why y equals 3 can still be a horizontal asymptote. So as I said before, the horizontal asymptotes are different from vertical asymptotes because they can touch or cross that point. Whereas vertical asymptotes are extremely like sacred ground, like you cannot cross or touch any point or would be considered a vertical asymptote. So in this case, we can say y equals 3 because it could still be a horizontal asymptote because when we cross that number, we can cross the number an infinite amount of times. So if y equals 3, then we will make that 3 our horizontal asymptote because that's where we cross the graph. Like we will cross the graph at 3 right here. So it could still go down. And don't worry about that typo.
Okay, so now we're gonna find a formula that has vertical asymptotes x equals 1 and x equals 3, and a horizontal asymptote at y equals 2. So I think it would be easier for us to start with the denominator because in order to have a vertical asymptote at a point x, the value of that point has to make the denominator equal to 0. So that means that our denominator could be x minus 1 multiplied by x minus 3. And here I set this, the two factors equal to 0. And we realize that x equals 1. So when x equals 1, one of the factors will be 0. And when x equals 3, the second factor will be 0 as well. So those two values of x will make the denominator 0 in both cases. So we can FOIL that out, and we have x squared minus 4x plus 3 on our denominator. So for the top, we need to find a polynomial with the same degree as the one in our denominator. And that way, they can, the value of the asymptote will be a number different from 0 or infinity. And we can prove that, so in this case, the denominator, the highest degree will be second degree, so it would be x squared. So we know that we have to have the highest degree on our top, it will be x squared. And I just added the coefficient 2 because the asymptote should be y equals 2. And just to prove that this is true, and I divided the top and the bottom by the highest degree, so it'll be the same as multiplying by 1 over x squared. And after that, I got 2 plus 6 over x plus 3 over x squared. And on the bottom, I got 1 minus 4 over x plus 3 over x squared. And if we plug in like larger and larger numbers into x, we realize that the right side of our equation, like 6 over x and 3 over 2x, 3 over x squared, sorry, would get really, really small. So they kind of like don't matter because they're so small that they're just a tiny bit. And we are left out with 2 over 1. So that means that the limit as x approaches infinity of f of x will be just 2. So that would be our horizontal asymptote. That would be y equals 2. You're muted.
For mine, it asked me to explain the process of finding vertical and horizontal asymptotes with the equation f of x equaling 1 plus x to the fourth over x squared minus x to the fourth. For the horizontal asymptote, what we did was I looked at the exponents, and because we're working with infinity, the x to the fourth would approach infinity at a much faster rate than any of the other variables that we have in this equation. So I decided to basically cancel out the other two and use x to the fourth over negative x to the fourth, giving me 1 over negative 1 equaling negative 1. For the vertical asymptote, same equation. I factored out the bottom, and because of that, to find the roots and set them equal to 0. So we would not need the top for this part of the equation. So from there, we have x squared times 1 minus x squared as our factor, and we set them both equal to 0. X squared equaling 0 and 1 minus x squared equaling 0. For x squared, we get x equals 0, and for 1 minus x squared equals 0, we get x equaling positive and negative 1 once we set them equal, or we solve for x. So that would be those would be our 3 vertical asymptotes for the limit approaching infinity, and our horizontal asymptote for the limit approaching infinity.
And that's our presentation on limits, infinity functions, and horizontal asymptotes.
Thank you guys. If y'all have any questions, you can feel free to ask them at the end of the presentation.